Algebra 2, Section 3.3, solving systems of linear inequalities. We have an example here that says Jenna spends at most 150 minutes a night on math and science homework. She spends at least 60 minutes on math. Write and solve a system of inequalities to model how she allots her time for these two subjects. By the way, if you are to look at the examples in the book, they're a little bit off from the examples on the software. It appears the software just left out an example. So what is example 3 in the book is actually shown as example 2 here. What is example 4 in the book is actually example 3. So this is off, is all I'm saying. This actually goes with example 3 if you read the example in your textbook. Anyway, we can write a system of inequalities based on this situation. Now I'm going to use the variables m and s, and because I kind of know what this is going to look like, I've gone ahead and made the scales to go by 20s, 20, 40, 60, 80, 100, like that. You might wait on that until you understand what your graph's going to look like a little bit better, but you'll see that this is going to work. So with those two variables, m and s, by the way, math and science, one doesn't necessarily depend on the other, right? This isn't an independent variable, dependent variable situation. So if you flipped the axes and this was your s and this was your m, it would be no problem. I just went m and s because math and science, just in the order that they wrote it. Okay, so the system of inequalities would look like this. M plus s is less than or equal to 150. You see, because that example just said that she spends at most 150 minutes. At most meaning she could spend less than that, but she's not going to spend more than 150 minutes on math and science homework. She spends at least 60 minutes on math. I like that. So that would be s is greater than or equal to 60. Okay. Now there's one other thing that could be included, and it's not really a focus of this section. It is in section 3.4. If you're watching this video in 2020, we didn't do 3.4, but I'm just going to introduce this to you anyway. And that is that math has got to be greater than or equal to, oh, I'm sorry, I did that wrong. This is m. Math is greater than or equal to 60. Science would be greater than or equal to 0. Okay, there is one more inequality that we could glean from this. We would know that she's not going to spend negative minutes on science. Okay, so there's really 3 inequalities, and because of that is why we have located into the first quadrant. You will need graph paper for this section. Obviously, it's about solving linear inequalities, which is all about graphing. All of the other examples we do will be 4 quadrant. So the graph paper that I should give you in class, or that you should grab off the back counter, would be the 4 quadrant graph paper. There's only one example like this. And you can just use the 4 quadrant graph paper, but you just only graph stuff in the first quadrant for problems like this. Okay, so let's go ahead and graph these. Really easy to graph this out of standard form. You plug a 0 in for m, you're going to get a 150 for s. You plug a 0 in for s, you're going to get 150 for m. That's 2 quick points. That is 150, 0, and 0, 150. I didn't even write those down because that seems so obvious. Again, you plug in 0 here, all you have is s equals 150. You plug in 0, you got m equals 150. And I'm saying equals because I need to get the line in place first. Then after I get the line in place, then we'll worry about shading. Graphing inequalities was a concept in a previous chapter, right? But now we're just graphing multiple inequalities on the same set of axes. Okay, so there we have that. Now, I gave you a rule back in the previous chapter that we were graphing inequalities, and the rule was that if the variable is by itself, if y is by itself, the dependent variable, or in this case, I guess we would say the vertical axis, the variable that's on the vertical axis, if that's by itself, then you can use a rule that is greater than is up and less than is down. If it's not in that form, like this is in standard form, then you can't use that, but rather what we should do is plug in a test point. Okay. Now, students will get confused by this, and you shouldn't. I plugged in 0 for m to get a value out for s to get this point right here. I plugged in a 0 for s to get a value out for m to get this point right here. Now I'm going to plug in the origin, 0, 0. Completely different reason to figure out the shading. I'm going to plug in 0, 0. And 0 is less than 150 is a true statement. That means I'm going to shade back towards the origin like this. Okay? So then there's m is greater than or equal to 60. The second constraint is what they really are, but second inequality. M is greater than or equal to 0. Well, here's the m axis. excuse me, I'm talking too fast. M is greater than or equal to 60. Here's the M axis, and that's going to be a line that's perpendicular with that. This is like X equals a number, but it's M, and here's 60 on the M axis. So I'm going to draw a vertical line at 60, like so. Notice that they're all or equal to, so I'm drawing solid lines. And the shading should be to the right. Greater than is to the right. Okay? And then finally, S is greater than or equal to 0 would just put us right here on the M axis, and we would be shading up. Okay? So notice where we pointed at 3 times. There's a particular region, and it would be this triangle right here. So you can shade that in. You want to make it really obvious what you're indicating as your final answer. And that would be this space right in here. Okay? Now notice, let me ask a few questions about this. Could she spend 80 minutes on math and 20 minutes on science? Just if you understand the situation, could you spend 80 minutes on math and 20 minutes on science? Yes, because that's more than 60 in math, and that's less than 150 total. So yes, she could spend that much time. And notice that 80-20 is in here. Okay? Could she spend 90-40? Yes, she could, because 90-40 is in here. Could she spend 90-70? 90 minutes on math, 70 minutes on science? No, because 90 minutes on math would be okay because that's greater than the 60, but also spending 70 in science would be 90 plus 70, which is 160. It's got to be less than or equal to 150. And notice that 90, 70 is not in the shaded region. That's why. Okay? So basically, again, the shaded region would be all the possibilities that work for this situation. Okay, just to do one more, let's do a minimum. Could she spend 60 minutes on math and 0 on science? Yes, she could, because that would be right here. 60 minutes on math, 0 on science. That's a solid line. That would include that point. Yes, she could. Okay, next one. Now we're just being given a system. There's no context to this, no backstory. We're just graphing 2 inequalities on the same axes. So those are both in slope-intercept form. So we'll go ahead and graph the y-intercept at -6 on the first one, and a slope of 3. You go from that point, and it's up 3, right 1, up 3, right 1, like this. And that one is or equal to, so we'll draw a line. And the rule that I just articulated in the last example would work here because y is by itself. If you don't like the rule, then just plug in a test point. The origin always works as long as the line itself doesn't run through the origin. And you can plug 0 in for x, 0 in for y, and see if 0 is less than -6. Is 0 less than -6? Well, it's not. And the rule reason why is because less than, right? If y is by itself, then this can indicate either greater than or less than being up or down. Less than is down. So we would shade this way. Okay. Looking at the second one, y-intercept of 2, slope of -4, down 4, right 1, down 4, right 1. Could also go up 4, left 1 a couple times. And this is going to be a dashed line. Use a straight edge and just go dash, 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 dash. I actually have a feature for that, so I'll use that. There's my dash line. Oh, why has it got to do that? Okay, and then the shading greater than is this way. It's up. Greater than is up. Okay. Now finally, and this is an important final step, you want to shade where you pointed at all of the times, right? In this case, it was 2 times. Then the previous one, there were actually 3. You want to shade where you pointed at with each of the lines. So that would be this space right here. The solution to the inequality is all this space right here. So shade or, whoops. shading like this. Or in some way make a clear indication where your solution set is. So this is all of this right in here. Sometimes I get a little carried away with my coloring. Okay, so that's the second example there. This one says solve the system of inequalities also, and now we've got an absolute value in there. By the way, y is greater than or equal to 3. It was going to be a horizontal line and then some shading. So we know how to graph y equals 3. This is greater than or equal to. We'll do that one first, and I'll draw a line. Solid at y equals 3. And then again, it's greater than is up. This is in that form where y is by itself, so we can simply shade up. And then the last one, or second one, y is greater than negative, the absolute value of x plus 2 plus 5. This is in this form that we've seen before. And h comma k was the vertex, so this would be negative 2, 5. We would interpret x minus h and x plus 2 to be minus a negative. So this is negative 2, 5. Negative 2, positive 5 is here. That's the vertex. This negative means that it's actually going to open down. And that negative 1 means that the slope as we go down is going to be down 1, right 1, down 1, right 1. So kind of a negative 1 slope here and a positive 1 slope going the other direction. It's greater than, not greater than or equal to. So I'm going to go back to the dashed line. As I draw this, it'll look like this. And incidentally, there would be nothing wrong at all with making a t-chart to make sure that you get this right. But we should recognize it in its vertex form too. That's the goal. Okay, now where's the shading? Well, it is in y by itself form. You know, a lot of times I say y equals form, except it's not equals anymore, but the y is by itself, so greater than is up. So the shading is this way, okay? So now think about it. Where did we point at twice? It was right here, not including this little bump. And everything up, because it was up twice. That little triangle there doesn't get included though, because that's not, that's only part of the solution set of one of the inequalities, not both. Okay, one more. What about the line y equals x? Do you know that the line y equals x is like this? Solid though. Okay, and I said a minute ago you can use the test point as long as the line doesn't, you can use the origin as your test point as long as the line doesn't pass through the origin. Well, this one does, so you wouldn't want to plug in the origin here. You'd just get 0 equals 0, and it wouldn't really explain anything to you. But you could use 1, 0, right? Plug 1 in for x and 0 in for y. Is 0 greater than 1? No. So we're going to shade the other way. But yet again, greater than is up, and that's the other reason why. Okay, and then here's the other one. The vertex here would be negative 5, negative 2. Negative 5, negative 2 is here. This one's going to open up, not down, but up like the last one. Unlike the last one, this one opens up. So watch what happens when we do this. When I graph like so, and then like that. Okay, and the shading less than would be this way. Now again, stop and think about it. Where did you shade twice? Where did we, where did we point at twice? And where's the Where's the solution to this system? You see it's all in this little space right here and all of this, right? That's where we shaded multiple times. Not inside here and not on this line, but everything that's in the middle here and this space. So you want to shade that or in some way indicate that that's your final space. I'll do the best I can here, but I'm not going to be very accurate with this clunky tool. All of this space right in here. Okay, now last thing I want to say is, what if the shading on the second one was the other way? What if instead of pointing this way like we did, what if it was the other way? Do you see then that the solution set to this would have been, now understand what would have happened if this were greater than we would have shaded the other way. And the solution set to this would have been the solution set to the system, because this entire graph lies up and to the left of this line, if you will. Okay, so that could have happened as well. All right, thanks for watching.